Hi, my name is Louis Savoldi, and for my final project, I will be presenting AWS Elastic Beanstalk. During this presentation, I will give you an overview of Elastic Beanstalk, an overview of a use case for using Beanstalk, and a demonstration of building, deploying, updating, load testing, and monitoring an application while deployed to Beanstalk. So what is Beanstalk? Beanstalk is an abstraction layer over the construction and destruction of AWS infrastructure components, allowing you to quickly build and manage highly scalable applications. So why use Beanstalk? At no additional cost, Beanstalk hides the complexities of the setup and configuration of your environment, while still giving you the same granular access as if you had constructed it yourself. Beanstalk comes in two flavors: a web server environment tier for web applications, and a worker environment tier for applications that do not have a user interface. It supports various platforms and has excellent tool support. Let's take a closer look at the web server environment tier. Beanstalk automatically creates an Elastic Load Balancer for you, an auto-scaling group consisting of one or more EC2 instances. Each EC2 instance includes an Apache web server, a Tomcat application server, all running on a Amazon Linux AMI. The important thing to note is each EC2 instance has installed an Elastic Beanstalk host manager. When you deploy your application ends up in an S3 bucket. Beanstalk takes that application version and deploys it via the host manager to each of your EC2 instances. For a demo application, I'll be building a concert ticket giveaway application for an upcoming YouTube concert. I'm expecting high volumes of traffic, and I have a very short delivery timeline. The architecture of the demo application is pretty simple. I have an Angular form that posts data to a Spring RESTful service running on Tomcat, which pushes data to a DynamoDB database. To simulate load on the application, I'm using Redline13 and a custom JMeter script. To begin with, let's look at the demo application. Users will be presented with a basic form to enter in their first name, last name, email address. Upon submit, data will be posted to my application server, JSON format that looks like this. The application server will log a message and push the content to a DynamoDB table. Let's take a look at my Eclipse project. Here you can see my folder structure. I'm using Maven as my build and the Spring framework to simplify some of my development. Looking at my dependencies in my Maven build file, you can see I'm including some files for DynamoDB. It's also a Spring data project for DynamoDB, the Spring container, Spring MVC for my RESTful web services, Jackson mapper from JSON conversion, and then some logging APIs. You can see my application is quite simple, consisting of 3 class files: a controller file, a domain, and repository class file. I have some configuration related to the Spring framework and the logging framework, a web application configuration file, and one HTML index file. The index file is simple. It's a simple form using AngularJS to post JSON data to a form entry URL. Looking at my class files, beginning with the domain object, you can see I have a simple entity class that maps straight to a DynamoDB table called form entries. That table is consisting of 4 fields: an ID, which is the key field, first name, last name, and email. Let's look at the form entry repository class. Not much there, is there? That's the power of Spring. It's a simple extension of the DynamoDB CRUD repository, which extends the Spring repository, providing us all of our CRUD operations. My form entry controller is also simple. Here you can see I'm annotating it with REST controller, which tells Spring that this is a RESTful web service, listening on the URL of form entry, accepting a post, converting the JSON content of the post to a form entry object. I'm printing the contents of that form entry, and then using my repository and basic save CRUD operation, I'm persisting the form entry object to my DynamoDB database. Let's use the AWS Management Eclipse plugin to set up my DynamoDB database table. Filling in the table name, my key field, and in a read-write capacity, I just hit finish, and my table is created. Now let's test the application. Right-clicking on my index file, run as, on server, Tomcat version 8, finish, application server starts up, application starts, form loads, Submit. I can see my entry there. My form updated me with my response. Go into the AWS Management Console, looking at the form entries. I can see my entries there. Now you notice I'm using the email address as the ID field, so if the form is submitted multiple times for the same email address, it will just overwrite the record. Now that we have our application working locally, let's go ahead and set up a production Beanstalk environment. Right-clicking on the app and choosing Deploy to Beanstalk, I'm going to go ahead and check and select my Tomcat 8 AWS Elastic Beanstalk application server. Give it a name for the application. Let's call this Concert Tickets. And the environment, let's call it Production. I'm going to leave it set to load balance environment. Hit next. Leave those to the default for permissions. I'm going to add my key pair so I can log into my EC2 instances. For the monitor URL, I'm going to just use the root, put my email address in there for notifications. Click next. Click finished. Now I need to set a version label. I'm going to call this initial release version 1.0. Hit OK. Beanstalk starts the build out and deployment of my application. After a few minutes and the build out is done and the application is deployed, we can navigate to the application. You can see the production URL and go ahead and test the form. Let's make sure everything's working. Hit submit. We got our response. Let's check our database. And we can see our John Doe was added. Now that we know that our production environment is set up and the application is running, let's make a quick change to the scaling group. To do that, we're going to double click on the production application Beanstalk server environment. We're going to move over to the configuration tab. Scrolling down, we'll see the auto scaling settings. We know we're going to receive an extremely high volume of requests. So let's go ahead and make this minimum instance count 8, and we'll make the max 15. Let's set the scaling cooldown time to 30 seconds. We want to be aggressive. We'll click Save. And you can see the environment is being updated. Clicking back over to our Environment Resource tab, clicking Refresh, we can see our instances have been created and are in a running state. Also from this tab, you can see that our instances were created across several different availability zones. You can see their launch times. You can see the key pair used, which would allow me to log into those individual instances. You can also right-click on an individual instance. You could reboot it from here, terminate it, or stop instances. Clicking back over to the Overview tab, here we can see our production environment URL for our application. We can see the application name, the current release that's running, and that our health status is OK. Just to reiterate that Beanstalk simply created all the environment for you and that you still have the same fine-grained control as if you had created it yourself. Let's just poke around a little bit on the AWS console screen. Clicking into the EC2 instance screen, looking at the instances themselves, here you can see the individual production instances that were created by Beanstalk. I can click on load balancers. I can see the load balancer that Beanstalk created along with the instances underneath it. I can look at the health check right here if I want to, and monitoring. I can also look at the auto scaling group that's been assigned. So again, you can see that Beanstalk really just hid the complexities of configuring all these different environmental pieces individually. Now let's walk through a quick promotion of a bug fix with a new version push to our production environment. Suppose I noticed that the header of my page was incorrect. I really wanted U2 concert ticket registration. I'm going to navigate to my index page, update the header, save, right click on the application, go to the Amazon Web Service menu, deploy to Elastic Beanstalk. I'm going to pick my production environment, click Next, Click Finish. The plugin's going to come back and say, what do you want to call this? I'm going to say we'll call it version 1.1. Hit OK. Now what Beanstalk's doing is it's pushing that version update to all the running instances for me. And you can see the header information was updated on the production URL. Clicking onto the production instance, clicking refresh, we can see the current application version that is running is the header text update version 1.1. Now let's look at Beanstalk in the AWS console application. At the top here you can see our application concert tickets. You can imagine if we had more than one application deployed. We might have application 2, application 3, application 4. Underneath each application you can see the environments at the top. Right now we just have one environment, a production environment, but if we had built out a UAT environment and perhaps a development environment, those would be listed here. And I can click into the environment and you can quickly see the health of the environment. Clicking back, I also have application versions. Here was the initial release version, and then here's the latest version update I did for the header text, and you can see that one is currently deployed to the production environment. Let's say we wanted to revert the production environment back to the initial release. It's as simple as clicking the version that you want to revert to, and then the deploy button, and then the environment. Deploy that initial release version back to production. Clicking deploy again is essentially Beanstalk's going to go out to each of those instances and update the version of the application. Now let's make an update to our scaling group configuration. Going back to the console, we're going to click on environments, drill into our production environment, click on configuration. Prior to me making any change, I'd like to take a snapshot of this current configuration. I'm going to right click on actions, save configuration. Let's call this default. Hit save. Now I'm going to change my scaling trigger and create a new configuration. We'll change the trigger measurement to CPU utilization, triggering it to create more instances when we go over the 50% threshold and reduce when we go below 20%. For configuration save, let's create a snapshot called CPU utilization. To help load test my application, I'm going to use an Apache project called JMeter. I built a simple script that will emulate 1,000 users. I'll ramp up over 5 minutes. The whole test will run in a duration of 10 minutes. Hitting the production URL, load the index page, wait 5 seconds to emulate the time it takes to fill out the form, and then post JSON in the format of the machine IP as the first name, the machine name as the last name, and then a generated UUID for the email address. Redline13 is a free tool that utilizes your Amazon environment. With it, you can upload your JMeter script, set your instance type, number of instances you want the script to run on, and then you need to add your subnet ID, which you can get from one of your production instances. Give the test a name, and hit Start Test. Clicking over back to the AWS console, you can see that the Redline instances are all starting. Each one of these instances is going to be running your JMeter script. While we wait for those Redline instances to start, let's take a look at the Beanstalk Health Monitor console. At the top we have an overview of our entire environment. Below is the overview of each instance. Scrolling across the overview, we have an overall status of OK. We have the number of requests per second. Right now you're seeing values from the load balancer hitting our instances. And then we have the distribution of HTTP status codes, 200s, 300s, 400s, and 500s across the environment. Information about latency, load average, and CPU utilization. And then the details per instance below. Another useful tool for seeing trending statuses is the monitoring tab on the console. Here you can see kind of a trending based on the time period that you select of latency, CPU utilization, and so on. This board is actually also customizable. I also want to tail one of the Catalina out files of my Tomcat instance on one of my running instances. Keep in mind as this test starts, I instructed Redline to spin up 8 servers running my JMeter script, which is surely going to overwhelm my server environment. Here you can see the requests are coming in. Remember, this is just one of 8 instances. The load balancer is distributing the load. Over here we can follow the distribution. We can see all of our requests are coming in as 200s. And the distribution across the servers is pretty even. No 300s, no 400s, no 500s, so that's good. Everything's looking okay. As the users are ramping up, we're just over 300 requests per second. Everything's still looking okay. Watching our trending, our lines are going up. There are the requests coming in. Again, this is just one of 8 instances. Requests per second still increasing. Still the environment is handling all requests with 200 status codes. Distribution is still pretty even. Redline's not reporting anything. Still going. Now you can see our requests per second are climbing. CPU utilization across the servers is still okay. Uh-oh, looks like we just had an issue here. The environment we're tailing stopped, and now we just got a warning. Looks like we're running out of memory. Oh, looks like we're running out of memory across multiple servers. In fact, it looks like my Tomcat instance just restarted itself. Kind of interesting. Yeah, this is not good. Lots of problems here. So you can see we overwhelmed the environment. Remember, we're running these micro instances. They have I think they have 1 gigabyte of RAM on them. So at this point, I would say this test is a failure. Our environment certainly could not handle the load we were putting on it. Options we would have if that was a realistic load is to, maybe increase the total number of initial servers, or perhaps increase the type of server from micro to medium or large, adding more CPU and RAM. Looking over at our Redline test plan, you can see it's logging all kinds of errors. Let's go ahead and stop the test. No point in continuing. Let's see if I can pull the instance off the log I was tailing to see what the problem was. Going to the logs menu, we can say pull all logs. Now it's going to pull a packet of logs from each instance. We'll need to figure out which instance we are on. Let's look at the IP address we were logged into, 11.16. Looking at our console of instances, we can find 11.16. The instance ID ends in 50B. And then looking at our set of logs, we can find the set of logs with 50B and start to download. Once downloaded, we'll unzip them and we can drill into them. Beanstalk does a great job of pulling in the needed logs. Let's look at the Tomcat Catalina log. Let's see what we can find in there. Scrolling through to the bottom, let's see what we can see. Here's our post being logged, but it looks like Tomcat just restarted on itself. Nothing there. Let's look at the system log. That's in var log messages. Let's see if we can find anything in there. Again, scrolling to the bottom. Oh, yep, there we go. Out of memory, killed the Java process. Essentially, that's how Tomcat was killed and automatically restarted. One last thing I wanted to show you is when you're done with your application, Beanstalk provides an easy way to destroy all the artifacts that were created as part of the Beanstalk. Simply delete the application. Beanstalk will go through and terminate all the various artifacts. On the Events tab, we can see Beanstalk terminate the instances. We can validate that our instances are actually all gone. Check the load balancer's gone, and the scaling group's been removed. That concludes my demo on Beanstalk. Thanks for watching. Please feel free to leave comments.